Today, we are going to talk about a basic understanding of fire load calculation in shipbuilding or cruise ship. So, what is fire load? Fire load of an enclosed space is a way of establishing the potential severity of hypothetical future fire. Fire load calculation require the assessment of all materials within the space, includes both the material being used in the structure and flammable objects or substances that may be stored in it. It is therefore a form of hazard assessment and is used to determine the level of fire risk that exists within a defined enclosed space. The requirement of fire load calculation is stated in SOLAS Chapter 2-2, Regulation 5. An enclosed space is required to comply both 3.2.2 and 3.2.3 requirement, where 3.2.2 stated that the calorific value of combustible material used on the surfaces and linings should not exceeding 45 mJ per meter square of the area for the thickness used. 3.2.3 stated that the total volume of combustible facings, moldings, decorations, and veneers shall not exceed a volume equivalent to 2.5 mm veneer on the combined area of the walls and ceiling linings. Here is an explanatory sketches showing the requirement for each components attached to bulkhead. I have defined that major 3 steps are required to compute the fire load calculation. Step 1. Identify combustible and non-combustible materials used within the enclosed space. Step 2. Calculate maximum calorific value of combustible materials. In Step 2, identify calorific value, density, or unit weight for each material from datasheet or material certificate. With the information provided, using the formula to calculate the calorific value of combustible material. If material density provided, the calorific value of combustible material equal to density multiply with material thickness and its caloric value in megajoules per kilogram. If material unit weight provided, the calorific value of combustible material equal to unit weight multiply with caloric value in megajoules per kilogram. If total mass of material used is taken, the calorific value of combustible material equal to material mass divided by the area used within the enclosed space multiply with the caloric value in megajoules per kilogram. Finally, check is the value calculated is comply to the requirement 3.2.2 where the calorific value of each combustible material should not exceed 45 megajoule per meter square. Step 3. Calculate total volume of combustible materials. In Step 3, compute the maximum permitted volume for an enclosed space by using the formula, where maximum permitted volume for the enclosed space equal to total surface area of wall and ceiling multiply by 0.0025. 0.0025 meter is stated in requirement 3.2.3 which is 2.5 mm veneer. Then, calculate the total volume of combustible material of an enclosed space which is equal to the total of all the combustible material surface area multiply its thickness. Finally, check is the value calculated is comply to the requirement 3.2.3 where the total volume of combustible material less than the maximum permitted volume. Now, let's see an example to calculate the fire load of an enclosed space. It's showing 4 meter times 3 meter office with 2.2 meter ceiling height. The material and finishing used is given. To compute fire load calculation, first we need to define which material and finishing is required to include in the calculation. Step 1. Identify combustible and non-combustible materials. Here the list of combustible and non-combustible materials for the office. The fireproof honeycomb for wall, fireproof glue for wall and ceiling slat in aluminium are non-combustible materials. Hence, do not require include in the calculation. Fixed furniture like cabinet, locker, and table are not required to include in the calculation. Although it is combustible as it is not applicable for both 3.2.2 and 3.2.3 requirement. Step 2. Calculate maximum calorific value of combustible material using the formula defined early and calculate the calorific value for each combustible material listed in Step 1. Check if the calculated calorific value of each combustible material comply with 3.2.2 which should not exceed 45 megajoule per meter square. The table show that the material used in the office is comply with requirement 3.2.2. So, proceed to Step 3, calculate total volume of combustible materials. Compute the maximum permitted volume using the formula. First, calculate the surface area of the wall which is equal to width times height, where height is ceiling height equal to 2.2 meter. There is total 4 walls for the office. The horizontal walls which is 4 meter and label as W1. The vertical walls which is 3 meter and label as W2. W1 calculated as 8.8 meter square while W2 is 6.6 meter square. The total surface area of all wall will be 30.8 meter square. Next, will be calculate the total surface area of ceiling which is equal to length times width. The ceiling surface area is equal to 12 meter square. With the 30.8 meter square surface area of wall and 12 meter square surface area of ceiling, the maximum permitted volume of office will be 0.107 meter cube. Last, compute the total volume of combustible material. As early, we have defined the combustible material or finishing as listed. Based on the dimension given early, compute the area and volume of each material. Total all the volume of the material will be our total volume of combustible material which is 0.040286 meter cube. Check is the total volume of combustible material, 0.040286 meter cube is less than maximum permitted volume, 0.107 meter cube. It show that it is also comply with requirement 3.2.3. Hence, this office is fulfill the fire load requirement as stated in SOLAS, Regulation 5. Thanks for watching. Hope you are learning and enjoyed this video. To hear from me again, do remember hit that subscribe button before you go.